Hey guys, welcome back. So today we're going to talk about the derivatives of natural exponents and logarithms. Maybe. Okay. So if we have y equals e to the x, this exponential function is actually a derivative of itself. And this is all on your reference sheet. So if y equals e to the x, y prime is also equal to e to the x. Now if we add an expression in the exponent, e to the power of ax plus b, then our derivative is going to be a, the derivative of the exponent, times e to the power of ax plus b. So we just bring the derivative in front and leave everything else alone. So let's look at some examples. If I have e to the 2x, that means my a is 2 and my b is 0. So we multiply by a and then leave the exponent alone. Here I'll try x times e to the negative 5x. So because it's a term multiplied by another term, we're going to use product rule. U equals x and v equals e to the negative 5x. U prime, the derivative of x is 1, and v prime multiplied by the coefficient in front, negative 5e to the negative 5x. So multiply it diagonally, negative 5x e to the negative 5x plus 1 times e to the negative 5x, and we'll factor out the common term, e to the negative 5x, and that's multiplied by negative 5x plus 1, or 1 minus 5x. And for our final example, e to the 3x over x squared. So because we're dividing the two terms now, we'll use quotient rule. U is e to the 3x, and u prime is 3e to the 3x, while v is x squared, and v prime is 2x. Remember that order matters, so we do v times u prime first, 3x squared, e to the 3x, minus u times v prime, minus 2x times e to the 3x, and that's all over v squared, which is x to the 4th. So let's simplify. I'll take out my common term, e to the 3x times 3x squared minus 2x over x to the 4th. Now these two terms have x, both have x's. So if I take an x away from everything, we get e to the power of 3x times 3x minus 2 over x cubed. Okay, so let's take a look at this equation. Y equals e to the 2x minus 9e to the x plus 7x. So the question's asking you find the x coordinates of the stationary points and their natures. So natures, remember, means if they're a maximum or a minimum point. So to find a stationary point, remember you find the derivative and set it equal to 0 and solve. Then to find the nature, we find the second derivative. If it's negative, it's a maximum, or if it's positive, it's a minimum. Let's go ahead and find the first derivative. Multiply by the coefficient of the exponent and leave the exponent alone. So 2e to the 2x minus 9e to the x plus 7, and we want to set that equal to 0. So remember, we're always looking for quadratics. This is in quadratic form, so you want to factor. We end up with e to the x minus 1 times 2e to the x minus 7 equals 0. You can do this in your calculator with the polynomial solver or a factor, whatever is easier for you. Therefore, e to the x equals 1 and e to the x equals 7 over 2. So take ln of both sides. X equals ln 1, which equals 0. Because anything to the power of 0 will give you 1 as an answer. Here I'm just going to leave my x value as ln of 7 over 2. So these are the two answers to part 1. To find if it's maximum or minimum, we have to take the second derivative of this equation. So take the derivative of the first derivative. So here when I multiply by 2, I'm going to get a coefficient of 4e to the 2x minus 9e to the x, and the 7 goes away. So here's my second derivative. We'll plug in both of these x coordinates. 4e to the power of 0 minus 9e to the power of 0 is 4 minus 9, or negative 5. So since it's a negative, that means when x equals 0, it's a maximum point. Let's plug in ln of 7 over 2. You're just going to put that into your calculator. I got 17.5, and that means when x equals ln of 7 over 2, we have a minimum point, since this is positive. Okay, so next we're going to talk about finding the derivatives of natural logarithms. The derivative, if my equation is y equals ln x, your derivative is 1 over x. Now both this and the other formula are on your reference sheet. If I have an expression, ln of ax plus b, the derivative is a over ax plus b. So let's look at some examples. I'm going to differentiate ln of 2x. So in this case, a equals 2, and since I'm not adding or subtracting a number, b is equal to 0. So if I plug it in here, we get 2 over 2x, which simplifies to 1 over x. So you'll notice if you have an x in here with a coefficient and no b at the end, no matter what that coefficient is, the derivative is still going to be 1 over x, because a over a will always simplify to 1. So let's look at another. ln of 4x minus 3. My a is 4 and my b is negative 3. So the derivative, a over ax plus b. And that's the answer. Okay, and the final part of the first example asks you to find the derivative of ln of 5 minus x to the 1/2 power, or the square root of 5 minus x. So remember, if you have ln of some term with an exponent, you can bring the exponent to the front. And we're going to want to do this so that we have a constant in front and don't deal with a fractional exponent. Be careful when they write it backwards. A is always the coefficient of x, so here it's -1, and b is the constant, which is 5. So y prime is equal to 1/2 times a over a plus b, ax plus b, or 5 minus x. And then we can just distribute to get -1 over 2 times 5 minus x. See these applications with the product and quotient rule. First, let's differentiate 2x to the 4th times ln 5x. If u is 2x to the 4th, then u prime equals 8x cubed. V is ln of 5x, and remember, if it's just something times x, your derivative is 1 over x. So let's see, 8x cubed times ln of 5x plus 2x to the 4th times 1 over x, and we'll simplify over here, 8x cubed ln 5x plus 2x cubed, and that's the final answer. Then quotient rule, ln of 2x over x cubed. My u is ln of 2x, and therefore u prime is 1 over x. My v is x cubed, and v prime is 3x squared. Remember your order. X cubed times 1 over x gives you x squared. Then I'll subtract 3x squared ln 2x and divide that by x to the 6th, because we need v squared. Now I can take an x squared out of all three of these terms, so we end up with 1 minus 3 ln 2x all over x to the 4th.